Welcome back. In this video, I'm going to introduce intelligent fire alarm panels. To this point, we've talked only about conventional panels, and quickly I just want to review how the initiating device circuits work on a conventional panel, just to differentiate, just to emphasize how the intelligent panels are different. So we've gone over this a few times. I'm not going to spend a lot of time. This is a conventional zone, and we know that they use current monitoring to detect either complete circuits, open circuits, or alarms. And they do that by using an N-line resistor that limits the current on the circuit. So we have a certain amount of voltage, usually around 24, at the front of the zone, and then we have all our normally open devices, and at the end we have this resistor. So the current can't go through any of the devices because they're normally open, and so it flows through this resistor, which limits how much current can flow, and the panel detects that as a complete circuit. If one of these were to go into alarm, let's say this is a pull station, and it shorts out, somebody walks up and pulls it, and now the positive and negative are touching, the current's going to take the path of least resistance. So it's going to go right through that pull station, the current's going to increase, and the panel's going to detect that as an alarm. If somebody were to cut a wire, no current would flow, and it would detect that as a trouble. Well, that's not at all how addressable panels work, or intelligent panels. You'll hear there is some difference between the terminology between addressable and intelligent, but from my experience, the two terms are used pretty much interchangeably, so we're not going to spend a lot of time on that. But so that's current monitoring, right? And an addressable panel or an intelligent panel uses something completely different. It uses data communication to communicate with all of its initiating devices. So on this little panel I've drawn down here, you can see there's two NACs on the left side. Those work the same way, for the most part, as a conventional panel. There are some differences that you can get into with programming and when they're set off, but there are also some conventional panels where you can do that. So the NACs, for our purposes, they work the same way. But on the right, you can see I've drawn this little thing, this just one circuit here, and it's labeled SLC, and that stands for Signaling Line Circuit. That's a terminology that a lot of manufacturers use, not all of them. Simplex and I think Edwards use some other ones, but the panels I primarily deal with use that terminology, and they all use some form of data communication with their devices. But whatever they call that may vary from manufacturer to manufacturer. So anyway, for all of our initiating devices, we can use just this one data loop. If you had, there are limits to how many devices can be on one of these, and that's panel specific, so it would depend on what kind of panel you're dealing with. But it's usually around, well, it totally varies, but let's say for our purposes I could fit 100 detectors on here and 100 modules. The difference between a detector and a detector would be an addressable smoke detector, heat detector, duct detector, possibly, yeah, I think that's probably about it. Modules, there's a whole bunch of them, we'll get into some, but for right now, just look at the pull stations I've drawn here, and those would be modules. And on some panels it doesn't even really matter. Sometimes you're just limited to 50 devices total, whether they're devices or modules. But let's wire this up real quick, and I'm going to do something a little bit different than I've done in the past, so you don't have to watch me draw all these two wires to each device. I'm going to draw these two little conductors, and they're going to go into a fire alarm cable, which is usually what you see in the field anyway. So now I'm going to make this a little bit bigger, and I'll just draw this cable, and just imagine that there's a positive and a negative conductor in here, right? So you can wire this up to each device. And now the way that the panel is going to talk to these devices, remember on the conventional system it used current monitoring. So you'd have the circuit, you'd have in and out of each circuit, and then at the end of the circuit you'd have a resistor, right? And it was very important that you go in and out of each device all the way to the end. Well, here I can do something called T-tapping. Depending on the style of wiring, there's certain systems where this is not allowed. We'll get into that in the future. Let's say I had a connection here. I'd have like some wire nuts and stuff like that. I can just tap off right here. I could tap off any way I want. I could make this, I mean, this is kind of confusing, but just to make my point, I don't have to go in any specific order. All I need is all of these devices to be somehow connected back to that panel, and I'll explain why. So the way this works is the panel is going to, when I install new devices, I have to go into the panel and program these devices in. I have to tell the panel that these devices exist. So let's label these devices. Let's say that this heat detector, and I can tell it's a heat detector because you can see that little gray ring at the bottom, that indicates that it's a heat detector. Let's call that device 1. then the smoke detector's 2, next smoke detector's 3, heat detector 4, 5, this is a pull station, 6, 7, etc. And then start over on the bottom, we go 8, 9, 10, etc. Well, I'd have to set an address on each one of those, and I'm going to show you how that works with most panels. Like I said, I'm basically going to be drawing a lot of stuff that relates to Firelight and Notifier because that's what I'm used to. On all the panels, you have to somehow give these an address, but it varies how you do that from manufacturer to manufacturer. But for Firelight and Notifier, this is typically how it's done. You see these two dials, and this would be on the back of the devices, or in some cases on the pull stations it'd be on the front of them. But there's a tens place and a ones place. The tens place goes all the way up to 15. The ones place goes to 9. If I wanted to set a heat detector at device 1, I'd leave the tens place at 0, and I would make the ones place a 1. So now the address is 0, 1. If I wanted it to be 159, I'd set the tens place. I'd have that arrow point at 15, so I have 1, 5, and the ones place at 9, it'd be device 159. So I think that's simple enough. Now once I pick the addresses in the field, I have to go into the panel's program and tell it, okay, device 1 is a heat detector, device 2 is a smoke detector, and so on and so on. And the panel is going to use this data communication to always check in with it. And that's the reason that I can just, as I said before, T-tap wherever I want, because as long as this is connected, the panel doesn't care what order it's wired in. At least again on a Notifier and a Firelight, it doesn't care what order it's wired in. As long as they're all on this loop somewhere, it's going to pull all the devices that I tell it should be there. So let's say I skipped device 3. I never told it that smoke detector 3 existed. I told it that 1, 2, 4, 5, 6, and 7 all existed. It would just check for those devices. So now, I'm going to get into that a little bit more on the next slide, but you can see down here I have this message. It says all systems normal. This is like a digital LCD readout, and some conventional panels do this now. Actually, a lot of them do it now, but this is another feature. There's more information on these addressable panels. For the most part, there's more information, and they give you an actual readout of what's going on. It's not just a little light that says zone 1 is an alarm. So that's kind of a little, I guess, not that good of an example of how this may work. But there's a date and a time, which is useful for when you're looking into history. It'll keep a history of all the events. You can go back through, and look up, well, what happened? Maybe you're going on a service call and panel's going into trouble intermittently. In the old days, you wouldn't be able to really tell what was going into trouble, whereas now these panels will keep a history, and you could say, okay, well, device 3 was intermittently going into trouble. But let's look at what we would have to tell the panel. I made this little chart that would be similar to what you would see if you were using some software to program this panel. So I'm going to go in, this is my example of kind of like a software interface that you would hook your computer up to the panel, or you could go and just do it through the panel's onboard menu. But there's a couple of important things that we have to tell the panel. So if we scroll back up, we had our devices were 1, 2, 3 was heat detector, smoke detector, smoke detector. And you can see at the top here, I have number 1 is heat detector, then smoke detector, then smoke detector. Well, that column I labeled type code. Type code is something that we'll get more into in the future, but it's basically the way that you tell the panel what type of device is out there. And there's a lot of different options. Like I can have a smoke detector. The smoke photo is a common type code for the Notifier panels, but I could have a smoke detector that doesn't cause an alarm when it goes into when it's activated. It causes a supervisory, so there's a different type code for that. I could have a fixed temp heat detector or a high temp heat detector, which would be like maybe 195 degrees or whatever. But anyway, so that's basically what the panel really cares about. It cares about this device number. It cares about the heat detector, and then we'll give it a label, and that's more for the human interaction with the panel. If it were a fireman that were coming in to figure out where the alarm was, that's for them. Or if it was somebody trying to troubleshoot a problem, that's for us. The panel doesn't care that device 1 is in a janitor's closet by room 306. It's not going to check the janitor's closet in room 306. It's going to check for device 1. So I could label this whatever I want, and it's only to help guide a user to that device. So you can see there's all, for each device I went through, smoke detector, and I gave it a label. Device 3, smoke detector, gave it another label, and so on and so on. And then there's this next line, which is control by event. And that's where these intelligent panels, that's where you could start to utilize some of the really unique mapping that's available to us with these intelligent panels. And it's something that I'm going to get into. I'm not going to do it in this video. And matter of fact, I think this is where I'm going to stop this video. So I'll see you in the next one.